Hello friends, welcome to the Cyberman Show. Today's topic is SOC or Security Operations Center, and I'm your host Prashant Mishra. So I'll be covering 5 things. One is what is SOC, the definition of it. Second, I'll be talking about why do people go with cybersecurity solutions or products. What kind of things or key tasks are involved in SOC. What kind of technology is used and what kind of roles or things people do in SOC. With that, let's get started. So SOC is a command post within a business that uses people, process, and technology to continuously monitor and improve an organization's security posture. Now, that's might be complicated for some of the people, but in summary, what it is saying is it is a place where people monitor the security posture of an organization. So I'll give you an example. Whenever you go to an airport or a train station, you always see security guards there. You see, in case of India, there is the CRPF that's continuously checking your identities and validating your flight time, and they then look into your baggages. Then they check you personally, and then there is always cameras or lying everywhere that monitoring the entire airport everywhere, right? So if I have to compare this in the cybersecurity world, there is a preventive control. So let's say there is a bad guy who wants to get into the airport, the CRPF or the police forces there can automatically stop them, this person or this group of people using the arms that they have. I would call this a preventive solution. Okay, while that happens, there is always a camera on somewhere which is recording the movement of every person in and around the airport. Okay, so this is a detection control or detective technology, and the people who are sitting on the camera are monitoring both preventive and detective solutions and in or situations, and in case they find a detective or an issue in the detection side, a new pattern that they see from a person that they have never seen before, they tell it back to the preventive team that anytime you see this new pattern, let us know, or you block them immediately. So example, if the preventive team sees a person carrying a gun, they immediately warn him, and if there is a gunfight, then they start firing back. That's a known pattern of a terrorist attack happening at the airport, right? But now there's a new pattern where somebody carries an arm in a different form, let's say liquid format, which was not known before. So then once it is detected, it becomes a protocol with the preventive forces to look for liquids or restrict the amount of liquid people can carry, and that's how the protocols at airports or train stations have improved, and similar things happen in the cyber side also, right? So what organizations do is they start with the process of discovering why do they need cybersecurity, what kind of attacks that they can have. So example, if you're an app that delivers food, and you have businesses running through your website or a mobile app, you would want to consider DOS or denial of service as an attack, and you might want to deploy a solution which protects your app from going down in case there is high amount of traffic. Okay, so that's one example. So they go through a validation or requirement gathering exercise with their internal customer consultants or external consultants, and they come up with these requirements, and for each of the threat related requirements or solutions that they need, they would deploy a preventive control, like a firewall on the network side, a web application firewall for a web application side, endpoint security product for an antivirus or employees who are working within the company, and so on and so forth, right? So preventive attacks do that, and then the next layer is the detective attack. So whatever is known will be recovered or will be protected by preventive attack, but whatever is unknown has to be detected by detective technologies, and that's where SOC comes in. Okay, and once the attack happens, there is a responsibility or the phase of respond on what needs to be done if this happens. If this new pattern is seen, what needs to be done, right? So people, processes, and technology all work together in tandem to keep the security posture of the company under watch and to make sure that the business is always running, it's always available, and nobody is able to compromise. Right? So that's the thing people do in SOC. Okay. The next part in the SOC side is the key things that the cyber team does, or the SOC team does, is essentially what they start doing is first they start with what assets are involved. That's the identification process, and essentially what that means is they have to find out what users exist in the organization, what kind of systems are there, what applications, endpoints, servers, etc. Okay, it depends on the how organization is using IT, and it's all about protecting what you know, right? What you can see, you can protect. So they make a continuous assessment of what assets belong to the company, and once they can track it, they can protect it. The second thing that they do is they ensure that the cybersecurity teams or the tools that are there, they are continuously updated to detect any known patterns of attack, and and ensuring that this is infrastructure is safe. And what happens is they have technologies which are deployed with policies, and they are monitoring these consoles, or they do proactive monitoring of their infrastructure. And the next thing that they do is manage logs. So logs are essentially audit records of everything happening. So example, when you log into a system, there is a log getting generated which says this person or this user has logged in. And whenever similarly you shut down, there's a log. When you switch on your system, there's a log. When you install a new software, there's a log, right? So for any activity that's done, typically there's a log generated by the system. The next thing is they track configuration change, they approve it. So example, if there's a new software that needs to be deployed, there's a new patch or update to a software, the SOC teams ensure that this new change doesn't change the security posture of the organizations, and they support, they allow or deny that configuration change based on the impact it's making to the organization. The next thing that they do is based on their monitoring activity, they rank the incoming notifications or alerts. So example, a notification or alert coming in for a system used by a CFO versus a system used by a food delivery person, in case of that food delivery business, would have different ranking or handling levels, right? So obviously you would want the CFO systems to be handled first, and based on your business needs. So that's how they rank it, and typically this is done automatically by the system by feeding certain parameters. Okay. The next thing is threat response. So in case there is a notification or alert, they would execute something called as workflow or SOPs, standard operating procedures, for each of the known possible scenarios that they have created. So example, going back to the airport thing, if the police forces or the security forces see a person walking in with the ammunition and an arm, they would warn him, and him or her, and then they start their procedure. So it's a known protocol, right? Same goes with the cyber side. And then if there is issue, so example, if the system goes down because of this security threat, they would start the recovery process. They also ensure that the systems or the IT infrastructure is under compliance as mandated by regulatory bodies, government agencies, internal and external auditors, or people who want to verify that you are maintaining the basic hygiene as recommended by these various agencies. Then, of course, they are always doing refinement and improvement of security posture based on the threats that are incoming. So example, when I started, there was nothing called ransomware. It's a new kind of threat that has appeared in the last 4 or 5 years, and the organizations are deploying new kind of technologies and systems in place to detect and block these bad activities. And then the last thing that they do is cybersecurity awareness. So they ensure that employees and partners who work in the infrastructure, they are always updated with latest threats. So they keep on sending emails, they conduct trainings to ensure that these people don't do anything that can be bad for the IT infrastructure of the company. Okay. So these are the key responsibility areas of SOC. Now, next thing we will discuss is the technology. So typically in a SOC, these are the technologies that are used. And it's not, I think I've covered most of them. I might have missed one or two things, but these are the most common things that are used. So SIM is first technology. What it does is it captures logs from all these systems, and it it has a policy engine, or as we call them, rule engine. And what it does is it matches all the incoming log data with that rule. So example, you might have a policy which says anytime there's a system login to a critical application after 10 p.m. in the night over weekend, send an email to the manager, because it's not a known activity. People typically don't come to office on weekends, especially if they're system administrators, so they would want that to be notified and then decide an action or threat response. So SIM collects all the logs for security monitoring purposes as well as compliance, because a lot of regulations also want you to retain logs for an year, sometimes 7 years, depending on where you are, which country, which location, which kind of business you are into. Okay, but 3 months to 1 year is the most common requirement. So they do two things. One is they monitor security logs against the rule engine. Second, they maintain or manage your log data. Now, the modern SIMs also use machine learning because making rules is hard. Patterns keep on evolving, but with machine learning, the system itself learns from the incoming data. So, it tells you or gives you an alert whenever there is an outlier. So, example, nobody logs in over weekend and the system says, hey, some people have logged in over weekend, so the system will automatically send you an alert. You don't need to create an alert. So machine learning gives you that advantage, and it's much faster and more accurate. The second thing which is commonly used in SOC is the EDR product. So EDR is endpoint detection and response. So it works in adjacency with EPP or endpoint protection platform. So this it's an antivirus essentially. It blocks all the known patterns of bad behavior. So example, a software trying to encrypt your C drive, and it's a known software that they have seen somewhere, so it will try to block it. Okay. Now the EDR works with this process, with this software, and with the EPP software. And what it does, it helps you detect and response, which means the analyst or the administration or the SOC team can monitor user systems and look at how this software got installed into the system. Did somebody went to a website and that led to that infection? Okay, so it helps you do detect and response also, which means they can isolate this particular endpoint in question and then investigate, and if their findings can be pushed to other systems for handling a future issue. Now, the third technology is the NTA-NDR. What it does is it keeps monitoring the network traffic in your infrastructure. So all the packets or data as it flows. For example, somebody browsing a website, a server talking to another server. So this product keeps monitoring like your camera in the infrastructure, right? So what it does is it records layer 2 to 7, as we call them in OSI, in the networking world. So it captures every packet. So example, when you're browsing, it will capture what browser you use, which website you went to, what kind of file you downloaded. In fact, you would be able to reconstruct the entire end user behavior or experience in this. Okay, so it's like the detection and response for your network traffic. So endpoint EDR looks into what happened on the endpoint. NDR looks into what happened in the network layer, right? So traffic has to leave the endpoint to make a connection on internet, right? That's where the NDR comes. The next product is the threat intelligence product. So this is essentially a database of known bad indicators and actors. So what companies in this domain do is they keep crawling or searching internet for known bad actors, and they keep put all this data in a database, and that database is integrated with all the above technologies like SIEM, EDR, EPP, NTA, and others to ensure that whenever there's a known connection to the known bad actor or indicator like a domain, let's say abc.com is a known domain, and an endpoint is making connection, so system will automatically block it. So it can go into prevent also, or it can send an alert in case you are integrating with SIEM. Okay. The next technology is UEBA, which is User Entity and Behavior Analytics. This is the machine learning part I was mentioning earlier. So what it does is captures data from endpoint, from log activity, from servers. It looks at your network traffic, it looks at your endpoint activity, and builds a profile of normal behavior. And whenever it sees an outlier, it gives you an alert. Okay? So this is the machine learning part. So when the industry started, UEBA and SIM were different products, but in the last few years, this is combined in a single product. So now EPPs come with UEBA, NT, NDR come with UEBA. So these are now integrated. But there are companies who are still operating at a standalone UEBA, and they, they integrate with the other categories of product. The next technology is the sandboxing. So this is a virtual simulation. What it does is it executes a file in a environment, a virtual environment, and tries to find what changes it is making. So let's say you email someone a file, or you receive an email with an attachment. The technology will take out that file, will run it in a Windows environment or a Linux environment, and then if that file is bad to your system or trying to, let's say, capture the keystrokes or whatever you're typing, it will send an alarm to the team that this attachment is bad. So a product can block your email. It can extract that data and send it back to the preventive system so that any other person receiving emails won't get it. Okay. The next technology is deception. Now this is a pretty interesting technology, because what it does is it creates a fake environment or a beta environment which looks like a real environment for her. So example, let's say you're going back to the example of a food delivery company. The crown jewels for that company are the customer data. It's data of me and people like you, with our home records, home addresses, phone records, emails, everything on that server, on one of the servers, and the hackers would come after it. So in the deception technology, what it does is it can create a fake environment, and when hackers get in, they see that this is a genuine, this could be a customer database, but essentially it's a fake data records planted by the technology and the SOC teams to learn patterns of attackers. What are they going after? Why are they going after it? They might not know, but what patterns are they using? Did they send an email to get in? Are they looking for a specific user, or they're looking for all the customer records, right? So the idea is to learn patterns of attackers and who those attackers are, and then they can use threat intelligence to find if this pattern is used by a known bad hacker or somebody unknown. Okay, in case there's no data. Now this helps them decide their strategic investments on cybersecurity and decide the next level or next upgrade of the IT infrastructure. The next technology is the SOAR technology. SOAR is security orchestration and automated response. So what this technology does is it automates the entire detection and response process for a company. So as I mentioned earlier, in most companies, what happens is you have rules running in SIM, EDR, NTA, all these solutions, and there are alerts, right, for each of the category, and SOC is monitoring those alerts. But what they have is also the workflows or SOPs for each known threat category. So example, if there's a phishing email that comes, and what they have is a workflow defining steps for handling those emails. So you find an email which has a bad attachment, what do you do after it? So every company has internally agreed upon steps, and they used to execute them manually, and this was a tedious process. So SOAR automates all this. So instead of carrying all those steps in a few hours, SOAR can automate that stuff, all those steps in a few seconds, and that's how it works. So I'll give you an example. Let's say for the same user who was trying to get into the system on a weekend. So in a normal environment without a SOAR, the SOC team will see a person logging in, and they will call up the user, they will call his manager, and they will get an approval on email that Mr. Manager, your reportee is logging onto the system. Is this approved activity as per you? Manager will say, yes, I'm approving this, and they will close the case and say, okay, this is known approved business behavior. Now this could take some time, let's say 5 minutes to connect to the user, speak with them, etc. But when there's a SOAR involved, the SOAR can automatically send an email to the end user mailbox and watch the mailbox. And if the manager says, yes, I have approved, the SOAR will automatically go ahead and close the ticket writing that this is a business approved action. So there's no human involvement. Now the idea behind SOC is to reduce the number of alerts that need manual investigation. So we are bringing automation to this side, and this is a technology that has grown up really fast in the last 4-5 years. Okay. Now, so those are the technology things in a SOC. Now, the next thing is the people part. So what kind of jobs exist in the SOC, right? So the most common job is the SOC analyst, people who understand these technologies and they investigate these alerts, and they carry out the investigation task and the response task. And then of course they need managers to give them direction. They also are familiar with people, the technology part and how softwares work with each other. They also look at developing content. So things like, let's say there's a new device version that needs to be integrated. So they would need some changes in the device and they need content developers. And then the threat researchers are there. Threat researchers try to keep their signatures on known patterns updated. So example, with the recent Russia-Ukraine cyber war, there are new DDoS tools, new ransomware, new data wiper tools coming in. So these researchers can find patterns and update their systems with these patterns so that in case their IT environments see the same pattern, they will automatically block it and they don't have to go through the pain of handling these incidents, right? And the entire team, ensures that the entire IT infrastructure, threat response detection process is continuously updated, right? So these are the roles involved in a SOC. Okay. So with that, that's it. Thanks for watching this video. I'll keep coming up with new content on this channel. If you have a question, please drop your notes in your comments and I will definitely revert back. Thank you. I'll see you next time.